So good morning, afternoon, and evening to our audience, and welcome to this lunchtime webinar entitled Catastrophe Modeling, Quantifying Current Risk and Modeling Future Risks under a Changing Climate, organized by the Young Second Subcommittee. Before moving on to the talk, there are few housekeeping rules to go over. I kindly invite you all attendees to keep your videos off and your microphones on mute during the seminar. We're going to have a Q&A session after all presentations. Therefore, please type any burning question into the chat at any point, but wait until the end of the presentation to get off mute and ask your questions to the speakers. Please note that the seminar is being recorded and will be uploaded onto our second YouTube channel. So by dialing into the event, you consent that any views or opinions you share are being made public. Else, please refrain from sharing any of the above. I'm Valentina Putrino, Catastrophe Risk Analyst at Ariel Re, and I'm chairing today's seminar organized by the Young Second Member Subcommittee, having been myself the chair of this group at some point in time in the past. For the ones of you who might not be familiar with the aim or the remits of the society, SECED stands for Society for Earthquake and Civil Engineering Dynamics, a forum for students, academics, and practitioners with an interest in earthquake, blast, and other types of dynamic effects, which, however, is expanding towards topics such as the one that we're covering today, which streams or is related to very closely to the world of engineering, including risk, catastrophe modeling, and climate change. Within SECED, members under the age of 35 are represented by the Young Second Subcommittee. Currently, there are 12 committee members who dedicate their time to organize a mix of activity directed to young members, such as this lunchtime seminar, the annual SECED Fund, and site visits. The current chair is our Marco Baiguera. There are two big upcoming events which I would like to remind our audience of. The Mallet Milne Lecture, which is the most significant event organized by SECED every other year. The 18th lecture will be given by Alan Pecker, professor at l'École des Ponts and Chaussées. He will give a lecture on the interrelationship between practice, standardization, and innovation in earthquake engineering. And that is going to take place on the 31st of May at the Institution of Civil Engineers in Westminster, London. And finally, a reminder of our Earthquake Engineering and Dynamics for a Sustainable Future 2023 conference in September in Cambridge. Stay tuned for many other events organized through our social media channels. Back to the talk now. Today's presentation is twofold. And it is with great pleasure and honor that I introduce the first speaker, Dr. Giacomo Sevier. Giacomo is the head of CAT Analytics at Aon Reinsurance Italy. He has a PhD in structural and earthquake engineering from the University of Pisa in Italy and Technical University of Braunschweig, Germany. In his thesis, he proposed an innovative Bayesian framework for the reduction of uncertainties in complex numerical models. As a postdoc, he spent 2 more years between the Technical University of Braunschweig and University College London, UCL, researching on uncertainty quantification and reduction in complex numerical modeling, mainly focusing on hazard and vulnerability modules of catastrophe models. Prior to joining Aon, he worked as analyst on a broad range of catastrophe modeling related topics for Zurich Insurance Group. The title of Giacomo's presentation is Natural Catastrophe Modeling: How Data Analytics Can Support Communities to Understand and Manage Natural Risk. And now on to Giacomo.
Thank you, Valentina. Let me share my screen. And please tell me when you can see it.
We can see it.
Okay, great. So thanks, Valentina, for your introduction. As you said, my talk will focus on catastrophe risk modeling. This is going to be a very high-level introduction to the topic, as it is a quite complex, let's say, and wide topic. So we might actually spend days talking about that. I don't know actually what the background of the audience is. So before really getting into the topic, I would like to give you an overview of the most significant uh, events, natural disasters that we had last year, just actually to somehow show you the reason why we need actually to quantify the risk from natural hazards, and that we aren't just speculating on the topic. So there is actually a concrete need. I put together some pictures, some figure, and I took the data from a report that Aon, the company I work for, issued at the beginning of this year, so 2023 Weather, Climate and Catastrophe Insight. If you are interested in having more information about the last year losses on a global scale, I would actually suggest you to have a look. You can find it online. And on this map, you can actually see, again, the most significant losses from last year. Two things I want to actually stress on this slide. So first of all, I know most of you probably have a background in earthquake engineering, but as you can actually see from this map, there are many other natural perils besides earthquakes. So particularly if you look at the US and Europe, most of the losses were generated by weather-related perils like windstorm, flood, tropical cyclones, and so on. Another important thing is actually that anytime that we want to quantify the risk, we somehow have to choose a metric, right, to quantify the risk. In the insurance and reinsurance industry, we usually use the economic losses. So we use a monetary amount actually as a metric for the risk. But these actually just show you an aspect of natural disaster, because of course, if you consider the monetary amount, so the economic losses as a metric, and you look at this map where we are showing the most significant event in terms of economic losses, you can really notice that it looks like all of the events happen in the wealthiest countries in the world, like in the US, Europe, China, Japan, and so on. Of course, what this map doesn't show, doesn't highlight, is the humanitarian crisis that is always behind a natural disaster. That's why I was saying that every time that you have to quantify the risk, you have to choose a metric. In other cases, for different reasons, you might actually choose different metric like casualties rather than human lives. So every time we work with risk, in my view, we always have to keep in mind that the metric we choose to quantify the risk somehow determine also the aspects that we are focusing on. Going ahead with the global losses of last year, if the total amount of global losses from last year was around 313 billion US dollar. And what is showing this slide is that in the last 22 years, but particularly if we focus on the last 7 years, we can really see that the trend of the losses on a global scale kept increasing. So again, quantifying the risk, it isn't something that we need to do, once in a while. It's something that we have to keep doing and also monitoring. So we have to monitor the risk and the evolution of the risk, because if you look at the last 7 years, 6th year over 7, we had losses above the average of the last 22 years, and particularly above 300 billion US dollar, which is a very high amount of losses. An important aspect of the what happened actually last year is actually the protection gap. I don't know how many of you are familiar with the insurance market, but somehow the protection gap that we observed last year, which was about 58%, meant that the 42% more or less of losses on a global scale were covered by public and private insurance, meaning that there was actually a significant transfer of losses from the community to the private sector, in particular to the insurance and reinsurance market. Again, of course, if we only look at statistics, we don't really observe and understand how also the protection gap is distributed on a global scale. Of course, there are countries, particularly the wealthiest countries, where the protection gap is higher, while there are some other countries like developing countries where the protection gap is lower. But anyway, this is a significant aspect to keep in mind. Finally, the last thing that I want to show you, again, because I know most of you have a background in earthquake engineering or in similar topics, and I actually have a similar background too. So sometimes we do really think that earthquakes are the most destructive events that generate the highest losses. Well, this is somehow true. So there are actually some severe events like the one that we observed at the beginning of this year in February. But if you look at the economic losses on a global scale and you average the losses on a like in the last 22 years, you can really observe that the weather-related perils are driving the losses on a global scale, like tropical cyclones, severe convective storm, flood, and so on. And this trend is somehow increasing because of the effect of climate change, and that's something that Annamarie will discuss later after my talk. And also because we are building in areas characterized by high hazard, some areas in the world where we didn't used to live, basically. So also the exposure is increasing, and that's why we have this increment in the losses on a global scale. So this is just to somehow give you a bit of background and context. So why we do really need to quantify the risk from natural hazards. Among the many tools that a risk manager can use, we also have the catastrophe risk models, also known as CAT model. The CAT models are very complex mathematical models that allow us to quantify the risk on a regional scale. So we can really analyze with all the limitation that a CAT model has, of course, but we can really analyze how the risk is on a regional scale or a country scale for very large portfolios. And this is really this is something really important, particularly if we want to design disaster risk reduction strategies, or if we are an insurance company, we want to quantify our risk. Okay. So in this slide, I wrote an academic definition, let's say, of a CAT model, just because I want to give you a reference of what a CAT model is. And let's quickly read it together. A CAT model is a computerized system that generates a robust set of simulated events and estimates magnitude, intensity, and location of the event to determine the amount of damage and calculate the insured loss. Here, I would actually say that the use of the application of a CAT model isn't just limited to the insurance industry. We can actually really use CAT models to estimate the risk and the losses, besides the fact they are insured or not. Okay, this is something we will see later in the presentation. Of course, I mean, the definition is, again, probably very insured oriented, because CAT models play a central role in the insurance industry as a result of a catastrophic event such as hurricane or earthquake. So again, this is something that allows us to estimate the risk on a large scale based on some event. A CAT model is usually composed of three main modules. So the hazard, the vulnerability, and the financial modules that we'll describe later in the presentation. And it takes as an input the exposure data. The exposure data means the location that we have in our portfolio, so namely the address of this structure, the construction characteristics like the construction material or the number of floor, the year of construction, which is related to the building code used during the design of the building. So we try to use any available information to really model with a quite good degree of accuracy our portfolio. And of course, if we are an insurance company, or anyway, if we want to estimate the retention of the insurance company, we also apply, and we have in the exposure data, the information related to the insurance and reinsurance structure. Finally, we get the ELT and YLT as result. The ELT are just the event loss table, the YLT, the year loss table. I will tell you the difference. But the main idea is just that the result of a CAT model is a list of event and losses, okay? That then we can use to make our statistics and, of course, support the decision of a risk manager. Okay, let's try to describe very briefly the three modules. So first of all, trying to describe the other module just in a slide is quite tough, okay? So just consider that this is a very oversimplification of the other module because I want to give you an idea of what a CAT model does. The other module aims at assessing the level of physical hazard across the area that we are investigating, that we are studying, of course, based on the stochastic event set. The stochastic event set, in my view, is a bit the core of a CAT model, and it is a database of events which are described by some intensity measure, like, for example, the strength, the magnitude of the event, the footprint, but so there are some parameters that describes our event. Of course, the definition, for example, of the rate of this event requires some specific analysis that I cannot describe here because we don't have time. But anyway, let's say that the main, considering everything that is behind the other module, the main aim of the other module is then to somehow translate and quantify the hazard on the area that we are analyzing. Here on the left-hand side, we have an example, a very simple example of the seismic hazard with a return period of 250 years in Italy. And these data, I just plot this data from the INGV. Again, something really important to keep in mind, since this model, the CAT models are quite complex and they have many, many parameters inside, and again, these are probabilistic models. There are many uncertainties and a certain degree of subjectivity in the calibration and definition of the models, okay? If we have to name a couple of sorts of uncertainty in the other module, we may think about the estimation of the rate of the events and the way we are describing these events, so the intensity, the selection of the intensity measure. Once we have the hazard, we want to understand how our building, our structure behave for a certain hazard level. And this is something that the vulnerability module does. And the aim of the vulnerability module is to assess the degree to which the structure and its content are likely to be damaged by the hazard. The vulnerability of a structure is actually described by the vulnerability curve that relate the damage ratio with the intensity measure that we are using to describe our hazard. I don't know how many of you are really familiar with the vulnerability curve and the vulnerability concept, but I guess some of you are engineers and you may think that for any structure that we have in our portfolio, we run some very detailed analysis like finite element models to determine the vulnerability curve. Well, it isn't the case. This wouldn't be actually sustainable because our portfolios are very, very huge in size. So, of course, we usually rely on database of predetermined vulnerability curves that refer to archetype buildings. And then, of course, around these vulnerability curves, we have a certain variability, which is related to the primary secondary modifiers. The primary secondary modifiers are just some construction feature that lead to a variation of the vulnerability curve and then allows us to better describe the vulnerability of our structure. So again, if you think about the way we are using the vulnerability curves, of course, there is a degree of uncertainty that we always have to keep in mind and to handle while we are analyzing our exposure. On the top of that, most of the time we have to deal with a reliable exposure data. Okay, so the quality of the exposure data sometimes add an additional layer of uncertainty to our analysis. So we have always to keep in mind that the result of our analysis is as good as the quality of our exposure data. Going ahead, the last module of a CAT model is the financial model, which actually translates the physical damage into a monetary loss. And also, in case that we want to quantify the retention of an insurance company or the retention of the reinsurer, it also applies the insurance and reinsurance condition. So I tried actually to plot it here at the bottom of the slide, so to somehow represent this concept. Starting from the left, we have the ground up loss, which is actually the physical loss without the application of any policy condition. Then, if we are an insurance company, we may be interested in understanding what is the retention of that risk, so the real risk that we are assuming with that portfolio. And so we apply the policy conditions, so limit and deductibles. In this example, we have a 10 million deductible and a 70 million limit. And this grayish area is actually the retention of the company before the application of a reinsurance structure. Then, of course, the insurance company may decide to cede part of this risk to the reinsurance industry. And so it buys reinsurance, we apply the reinsurance condition, and part of this risk goes to the reinsurance industry, while the orange part is the retention of the company. Very briefly, the reinsurance industry is just basically an additional layer that we have, let's say, that sit above the insurance industry, and it actually allows insurance company to underwrite large risk somehow. So it's a kind of insurance of the insurance companies. And I work for Aon, which is one of the biggest reinsurance broker in the world, and we actually sit in the middle of these two markets, and we facilitate the transaction between the two markets and the transfer of risk. So basically, that's what we do. Going to add, as I said, the results of a CAT model are the losses, and they may be expressed in terms of event loss table or year loss table. The difference between them is just that in the case of event loss table, we have the ID which identify the event and the rate of the event. Mean loss is a standard deviation. In the case of the year loss table, we don't have actually explicitly the rate, but we have the analysis here that, of course, can be used to estimate the rate. I mean, there are pros and cons of using one approach instead of the other. But what is important at the end of the day is that these results are used to quantify the risk according to some metrics, some statistics of the result. What we usually use in the market, in the industry, in the insurance industry, is the average annual loss, which is actually the expected loss per year, average over many years, of course. The occurrence exceedance probability curve, which is the probability that the largest loss in a year exceed a certain amount. And the aggregate exceedance probability, which is similar to the occurrence exceedance probability, but in that case, we consider the sum of losses in a year, okay? And these three metrics give you a different view of the same risk somehow, because, for example, if I'm a insurance company and I want to understand the retention of my risk, I would probably look at the average annual loss because it gives me an idea on how on the money that I have to retain in order to sustain the business. While if I'm a risk manager that wants to design, for example, a disaster risk reduction policy or measure for a certain return period, I would probably look at the occurrence or aggregate exceedance probability, because as you see here at the bottom of this slide, this gives you also the losses for different return periods, so you can really calibrate your method for a certain return period. Very briefly, this is something quite important, the concept of view of risk. This is one of those topics that we could discuss for days, I think. So I will try just to give you a very high-level introduction of what a view of risk is. As I mentioned many times during this presentation, we have many uncertainties within the model, and sometimes we have to make some choices in order to design our model, right? For example, when we define the rate of the events or the vulnerability curves. The result of the model may not reflect the view of risk of our stakeholder, okay? The view of risk of our stakeholder means, for example, they may not match their risk profile or the experience that they had during past events. So when we develop the view of risk for one of our clients, or in general, where an analyst has to develop a view of risk, it means it has to really calibrate somehow the model in order to reflect what the risk profile and the past experience of the stakeholder is. This is a very deep and comprehensive calibration, which require any available information. So you may use information from past events, historical losses, losses from the market, data or information about the built environment, any presence of risk mitigation measure. You try then to use all of this information to somehow recalibrate or adjust the frequency of the events or adjust the losses directly, recalibrate the vulnerability curve in order really to match your experience. And if you look here on the right-hand side in this small picture, we have the orange curve that is the pure modeling result, and the blue curve, the one that has a weird shape, that is the curve derived from the historical claims that we may have in our portfolio. And then we develop the view of risk of our model, and we adjust the results, all of these parameters, in order to have a result of the model that somehow match our empirical experience when it is available. And so we get the green curve. Again, this is a very complex topic. What I want to mention is that anytime we want to use CAT models, we really have to think about the way we are deriving the results and what the result is reflecting, and if it is in line with the view of risk of our stakeholder. I want to just give you an idea of what the result of a CAT model is. So I put together a very simple example. Again, as Valentina said, I'm working in Italy. I'm the head of the CAT analytics team in Italy, so I'm using Italy as a reference. I created a dummy portfolio that you can see here in the middle of the slide, and the radius of these cycles are related to the value of the exposure, okay? So I randomly generated this portfolio basically with 1,000 locations. As you can see, the exposure is quite random, so we have some cycles that are bigger than the other, but what is important is just that it's something that you may find in a real problem. On the left-hand side, we have the seismic hazard. So again, that's the same picture I showed you before, just because I want to represent the elements of our CAT model. And I just consider different construction classes within our portfolio. So we have some reinforced concrete buildings, reinforced masonry building, and steel buildings. Okay. What I want to show you is just the results of this of the model. So if you look at the location AAL, there's and now the radius then of this cycle are related to the average annual loss and not to the exposure anymore. This new picture doesn't really match the one that we had in the previous slide. Because of course, and you may notice that we have the biggest cycle in the Apennine region and in the northeast of the country where the hazard was higher, while in the northwest of the country we have these small dots because of course the hazard was much lower. And here on the right-hand side we have the OAP and the AP curve. And again, these are the tools that we may use to make, let's say, that may actually support decision makers to make more informed decisions. Something important to note, maybe because you are more interested in earthquake than the other period, and you may actually notice that the OAP and the AP are quite close when we analyze an earthquake, a seismic model, an earthquake portfolio, because of course the number of earthquakes of events per year that are really the strong events that are generating the loss is quite and are really, let's say, contributing to the losses. It's quite small, and so all the other events are usually contributing less to the year loss, and so that's why. So you have just a small number of events that are really contributing to the losses, and that's why you have these two curves so close. Very quickly, I want to just mention, since I mentioned many times the uncertainties that we have in our model, and we had these very extreme events in February this year in Turkey and Syria, I want to just mention some of the challenges that we may have when we want to model such an extreme event. Two things very quickly. We spoke about the uncertainty and in the estimation of the vulnerability, which is related to the construction characteristics or any other information about our buildings. And I would guess that most of, if we had actually to analyze a portfolio in Turkey, in that region, we would actually have underestimated the vulnerability because, of course, according to the information that were available, nobody, I think, was expecting such extreme collapses. Like in some cases, we observed some pancake collapses, even for construction that theoretically were designed with the latest building codes. So something that we don't really expect. And besides that, another thing that is quite challenging to model is the damage accumulation where you have a seismic sequence. Okay, this is something that most of our CAT models don't capture. At Alien, we are actually working to somehow extend our modeling capabilities and also incorporate this and model somehow the seismic sequence, but it's for sure a challenge when this happens. Okay, so very briefly, how these CAT models can be used by risk manager to really quantify and potentially design policies to reduce the impact of natural disaster. I think there are two main field of application. So one, the one that I mentioned right from the beginning of the presentation, is the insurance industry. CAT models actually got quite significant momentum in the early 90s in the industry, in the insurance industry. And now they are playing, the results of CAT modeling are playing a central role. So they are using for capital modeling, underwriting services, regulatory, reinsurance pricing, anything related to ESG and climate change, accumulation, stack and clash. So they really play a central role. But I also think that the insurance industry play a central role somehow in the society, because it allows us to somehow transfer part of the risk from the society to the private industry. And so it really helps to widespread, to spread the risk among a large number of people. And if you think about international insurance companies, we are really spreading the risk and among all around the globe, basically. And we wouldn't be able to do that without the insurance industry, for sure. But I wouldn't say that CAT models, the use of CAT models has to be limited to the insurance industry. We may actually have national or regional bodies that use CAT models to really design disaster risk reduction policies. If we just take a very simple example like the one that I showed you before, when you look at a portfolio like the one we analyzed, we may think, for example, these are all public buildings. You realize at some point that the number of risk the number of locations, sorry, that is driving the risk is quite limited. So you can actually really use the results of a CAT model to prioritize the intervention on the built environment. I did this very simple example, so you can really recognize which are, let's say, the top X locations that are contributing to more than, I don't know, 50% of your average annual loss. And then you can design a mid or long-term policy to start reducing the physical risk. So you may actually found, I don't know, public intervention of this building, and so retrofit this building, meanwhile keeping an insurance in order to find a way to transfer the risk to the insurance market. So through an insurance pool rather than any other financial tool. So just actually to mention that we can really use this tool in other contexts. And in this very simple example, if we retrofit the first 30, 40 risks, I don't remember, we can manage to reduce the losses by 30% with a return period of 200 years. So again, this is something that, of course, cannot determine the policy of a country, or it shouldn't actually really. We shouldn't actually let the model decide, but at least we should use our model to support the decision makers for a better management of the natural risk. Finally, before closing the talk, I want to mention the main challenges that we are facing nowadays in the CAT modeling industry. There are many, many issues. So again, we may actually talk about that for hours. But if I have to name three main issues, I would say data quality. In my view, that's the elephant in the room. I mean, it's really important. Sometimes we don't have enough quality. We have exposure data which aren't reliable. And so, of course, the results of your analysis will not be reliable as well. Climate change modeling is something that Annamarie will explain in a few minutes. And the accurate representation of uncertainty. Again, CAT models are really complex model. There are many uncertainties in it. And of course, we really have to handle these uncertainties in the right way, so propagate the uncertainties through the model, recognize the uncertainty, and I also think we do really have to communicate the uncertainty around the results of the model. And that's pretty much all. Thank you, everybody. And of course, if you're interested in knowing a bit more on CAT modeling or any topic or anything that we do in Aon, just feel free to reach me out. Thanks, Valentina. Over to you.
Thank you, Giacomo, for the presentation. And now to follow, we have Annamarie Buttner, Lead Climate Risk Solution at Swiss Re Corporate Solutions. In her role, Annamarie enables companies to identify, assess, reduce, and report the impacts of climate change to their businesses by combining latest scientific knowledge with in-depth risk management experience. Before entering the insurance industry, Annamarie gained experience in engineering consulting at Fitchner Consulting Engineers in Mumbai, India. Furthermore, Annamarie worked at Zurich Insurance as senior natural catastrophe analyst and junior risk modeler, managing international natural catastrophe portfolios. More recently, she worked as climate risk and insurance consultant at the Swiss Re SME, which included the creation of TCFD reports for corporate clients. Annamarie holds a master's degree in environmental engineering from the Technical University of Munich. And she will be talking about quantifying climate risk, how future climate models help us to prepare for the future. Now on to you, Annamarie. Thanks.
Thank you, Valentina. Thank you, Giacomo. And thank you very much for inviting me and talking about this a bit exotic topic of climate change, which is not super closely related to earthquakes, but still super happy to give you an idea of how we're managing this and how we're supporting our clients. Let me quickly open up my presentation here. I hope you're seeing my screen. Fantastic. And let's jump right into it. So from what Giacomo just explained, which was very much like models looking at the past with climate change, we figured out for some perils we cannot rely too much on the past anymore. So we have to come up with different methodologies on how to assess these risks and look more into the future. So I don't think I need to go too much on the background of climate change. I sit in Switzerland. We used to have fantastic glaciers. They are in retreat, and this is something that can be monitored. And of course, we got the overwhelming scientific community agreeing on the fact that climate change is happening, and it's human-made. And over the last years, the trends have been increasing, and thus it's impacting us pretty much everywhere around the globe. The close ties to the CO2 emissions are also something that where the evidence has been provided, and there's different greenhouse gases, which are often described as CO2 equivalents, because CO2 is the biggest or the most prominent one. And yes, so if you want to learn more on the greenhouse effect, please feel free to look that one up. But I will jump right into how we're actually using these information. From natural variability to looking into the future and into climate change. The data that we are using a Swiss Re, and which are pretty much the standard, is collected by the IPCC, which is the Intergovernmental Panel on Climate Change, very important name. They are a UN body, and they are they're providing assessments and collect data on climate change from the various research institutions. They have different reports, different working groups that they're publishing every year, where the scientific consensus is summarized. There's also very comprehensive reports of them. And one of the reports of the third working group, which is about mitigation of climate change. And here, us as engineers have an important role to play in preparing the world also for a different climate. Right. What does a different climate mean? We, of course, don't have the crystal ball either, but there are scenarios that are defined by the IPCC, and they are based on how much CO2 emissions will happen in the future. So there is 5 different scenarios in the AR6 report. They're called SSPs, socioeconomic pathways, shared socioeconomic pathways, and they reference to the RCPs, which were previously how the scenarios were called. So basically, how it works is SSP1 is a scenario that that works under the premise that we are reducing our emissions significantly. We are keeping our warming until the end of the century at around 1.5 degrees, while there is the SSP2 scenario, which is already which is called the middle of the road scenario, and it's already rather a bit often called as the most realistic scenario at the moment, where the global warming by the end of the century will be rather towards 2 to 3 degrees. And then there's SSP5, which is a scenario where we're not achieving and reducing our emissions, and it's called fossil fuel development. So there's going to be economic growth, investments rather in technologies to adapting climate change and societal control, rather than in reducing the emissions, and that is expected to have a increase in temperature of 3 to 5 degrees by the end of the century. And these scenarios are important whenever we look into the future, where we're not considering just one. It's important to always keep them in mind. And yes, we focus on the SSP 1, 2, and 5. And the reason we're looking at these is also called the concept of double materiality. So because companies, on one hand side, they are emitting, they are often heavily emitting, like the cement industry, and thus driving climate change or contributing significantly to it. The cement industry, for example, has roughly 8% of the global CO2 emissions are driven by this very CO2 heavy industry. And on the other hand side, because then it comes back to the companies and to the businesses, is that climate change also has an impact on them in return, in terms of increased transition or physical risks. We saw already on Giacomo's first slide that not only earthquakes and storms are the big loss-driving events of last year, but I also saw 2 pretty red drought or pretty significant drought dots. And so we are going to see more of these, especially in Europe. In the last year, there were quite some losses from this significant drought, and also we had a very dry winter. And yes, so let's hope that not another drought year is following. So this is the double materiality. On one hand side, companies emit CO2 and influence the climate. On the other hand, the climate is also influencing the company through this increased risks. There are different types of risks, and probably everybody that went to physics class in the last 20 years and heard a bit about climate change has seen such a picture with all the things around the globe that are changing, like the increase of droughts and wildfires, permafrost is retreating, change in storm patterns, corals are severely damaged, and also the rise of the sea level. And in addition to this change, this physical change, I also see among of course humans, among the businesses that I'm talking to, also change in the mindsets of companies that want to try and drive drive a sustainable development as well, and work on, for example, circular economies. And there's a lot of great ideas out there on how climate change can be mitigated and how companies want to adapt then to climate change. The focus of this talk is physical climate risks. There is also the very wide topic of transition risks, which are risks that are impacting companies, businesses, not physically, but for example, the reputation of a company can be impacted by not being sustainable, or legal impacts maybe coming up as there is more and more lawsuits of people that have lost their homes due to climate change, and they want a compensation from the corporates that have caused the biggest emissions. So these are transition risks, but we're really focusing on the physical part with this talk. So the consequences, can be modeled. So there is global climate models which give an indication for the different scenarios and years into the future, how, for example, the precipitation patterns are going to change, for example, towards more extreme precipitation or towards more drought events. Here's another map of the surface soil moisture. Also there we see that there's regional differences around the globe, and with Europe becoming a lot drier over the next decades. And yes, sea level rise, another big topic for especially countries around the coast, of course, and there the amount of sea level rise is very closely linked here as well to the climate change scenario that we're gonna head for. So yes, it's about more extreme precipitation patterns, which is, for example, a change in the intensity of the events. More often drought events, which is a change in the frequency, and then also the long-term chronic developments such as sea level rise. All right. Now let's tie this climate science to natural catastrophes, as Giacomo has set the stage. Temperatures are already up by 1.1 to 1.2 degrees compared to pre-industrial times, and even more, like 1.9 in Europe. And I mentioned that the frequency and intensity of events is changing, and also record-shattering events, which means events that have really never seen before in the region, are changing significantly. With +2 degrees global average temperature increase, we can also say that roughly the rainfall amount in tropical cyclones is increasing by 10%. So hurricanes like Harvey are becoming more the norm, which are very heavy events where the losses are driven by flood and not by the impact of the storm, for example. And also extreme temperatures, like very warm years, which used to appear only every 10 to 50 years, are becoming 6 to 14 times more likely in a +2 degree world. So it's really not just the change of the average temperature, but we really have to look at the extremes, which can become unprecedented. So events that we have seen before, I mentioned the various events like the Western North America heat waves and wildfires. These were this heat dome last year, where in Canada the temperatures went up to 46 degrees Celsius. That was 4 degrees higher than ever measured in this area. So a huge jump in the extremes. And then also the heat in France and drought in France last year. I mentioned bushfires in Australia, but also wildfires in California becoming a lot more frequent, and we're almost every year breaking the records of the biggest wildfire ever recorded. So there we clearly see a trend on the events. And let's look at how Swiss Re is doing that, which is of course just one of the ways of approaching this this very complex problem of physical risks driven by climate change. And what we are doing, what I quickly would like to introduce to you, is a tool called the Sustainability Compass. And it combines today's climate risk, meaning the risk of floods, storms, as we can see the risk today. Taking the risk into the future, there we use climate risk scores, which is a scoring that tells you how much the risk is going to change, and combine that with nature risk, which is methodology developed by us, which gives you an impression of which nature services that are received within a region. Nature service may sound a bit abstract, but it's very simple things such as the amount of fresh water available, clean air, fertile soil, or pollination. These are all services that we receive from nature as humans or as businesses. And in the European Union, there is the EU taxonomy that is a framework where companies have to report their physical climate risks. And TCFD is also a reporting framework for being transparent on the risks that companies are facing in the future. Let me skip that in the interest of time. I mentioned the climate risk scores. This is actually the core piece I'm going to speak about in a sec. So for the three different scenarios that I mentioned before, SSP1, SSP2, and SSP5, we'll look at 12 different hazards such as floods, wildfires, or sea level rise, and see how they are changing over the coming decades. So every 5 years, we develop such a score. From 0 to 10 as mentioned, and it's a 30-year moving average, so it ends in 2085. And this is kind of the end of the century view. To translate these scores into real applicable categories, we have introduced the hazard risk categories, which give you an impression from very low to very high and extreme how the risk is developing over time. So for example, you're in a location where the current risk of being impacted by a wildfire is rather low, but with the changes in the precipitation patterns and in the temperatures, the risk of being impacted by a wildfire may actually increase to moderate by 2030 or even to high by 2050. So these are the impacts that need to be seen. Right. So in the end, what our clients are big corporates, and how they typically work with that is they want to understand where climate change is impacting them, when it's becoming the risk is becoming really intense, and how they can mitigate it, what they can really do about it. And so climate risk adaptation plans and climate risk strategies are really high on the agendas of many corporates at the moment, especially when it comes to selecting new sites, deciding on where to invest. And these risk considerations need to be taken into consideration here. All right, in addition to the scores and to the tool, just to be very brief, it's often the case that we're working with our risk engineers rather closely. This means that in addition to the underlying data, it's also important to bring a risk engineer in. Once we've identified the flood risk is increasing, the wildfire risk increasing, of course, the next question of any corporate would be, what can we do about it? And so there we can really see the overlap with risk engineering and the importance of working with really hands-on people on the ground that come up with solutions and recommendations. So yes, it is all about prevention of losses and control, monitoring the risks, and having also the risk transfer solutions that Giacomo already mentioned, that in our industry, the insurance industry, are rather typical to be seen. All right, because talk is good, but maybe seeing the tool is even better. So I prepared very briefly a short demo for you guys that I quickly wanted you to take a look. This is the sustainability compass. Please, let me know if you want to see anything in specific. But as we are all earthquake people, or you guys are, let's start with earthquake and let's quickly pull up some earthquake insights. It's a rather rough map, but representing the entire globe of how the earthquake risk can be seen around the globe. Earthquake is not a climate risk. It does not change with the influence of climate change. So for me, it's rather a side topic. For you guys, it's probably a bit more important. But anyways, I want to start out with that one so you get different rates of earthquake and PGAs. Yes, depending on the area where you're at. But hopefully also important for you is flood. So let's look at some flood maps and let's get a bit of an idea of how the flood risk is developing. So coming up are some flood maps. Here we see in the region of Germany, these are the official flood maps by the German government. And in addition, we also have some Swiss Re flood maps, which is a global flood map because the official maps are not available all around the globe. So for example, here we can also look at African locations and how the flood risk is there. For example, here, oops, it takes some time to build up. I'm not that patient at the moment, but anyways, it's a rather comprehensive tool then, looking at the maps. But let's also, most importantly, understand how the risks are developing. So, for example, we want to look at the flood risk, fluvial flood risk for the climate change scenario. Let's go most extreme. And we want to look at the year 2050 because that's typically the time frame that we're planning our investments maybe for. And also the reporting goes until maximum that time frame. And we toggle this on and we see that different locations are having different flood risks, and the flood risk is developing in of course, not everywhere. And there is sites, for example, here in the UK, closer to you guys, that are impacted by a flood. And let's turn this on one more time. Here we have a site that is close to the river, and you can draw a polygon of that site. And it's not only impacted by flood at the moment, also the risk is changing. So it's going to become more severe in the future. Let's take a closer look at that location. And we can look at the natural hazards of that site. Just a second. So it's in a 100-year return period flood zone. And earthquake risk is low, nice in the UK. The windstorm risk is moderate. That also seems okay for the region. Lightning risk is low, and the rest of the risks are really very low. And when looking at how this is developing, we can turn on the next page and see again, select the different climate change scenarios, looking at fluvial flood risk. So the riverine flood is especially increasing for the SSP1 scenario after 2050. For the other scenarios, maybe let's select the most extreme one. Let it load for a second. So there we see that the increase in the flood risk is starting much earlier already now, and then it's going to increase further. So compared to here, we see the fluvial flood risk stays the same for SSP1 and probably is changing the categories then for SSP5. Let's get surprised. All right, I'm a bit impatient here. Right. So this is how you can look at this tool and investigate your locations all around the globe. Also, especially important for clients, as mentioned, that are investing in new sites that want to be up to date. And yeah. Back to my presentation, just a second. Yes. In the interest of time, just the last few minutes. So what companies are already doing with tools such as ours is, as I mentioned, the EU taxonomy reporting. One client was an IT supplier and they needed to report on the EU taxonomy for the first time. So they worked with us on their physical climate risks, did the assessments in the Compass tool, and also got a portfolio assessment report from our risk engineering team assessing all their locations around the globe. And not only could they fulfill the reporting, which was of course nice to tick that box, but also because this topic was so new to them. They didn't know about their climate risks or natural catastrophes before, and they could really identify some locations where they will put measures in place to reduce the risk. The focus here was on flooding, but also on heat. And especially as this is an IT supplier, they need cooling systems and real like a stable temperature level. This was something that they were really, was a good insight for them to prepare. Another company that we're working with is a oil and gas company. They are already impacted by climate change. They sit in Asia, so flood is a big topic for them. And also another topic, as they want to also heavily invest in renewable energies, is to raise awareness for the whole topic of climate change and the fact that we can quantify climate change now, we can quantify expected losses from it, and thus it's no more this this gray cloud above us that we get reminded of in the newspapers, but it's something we can quantify and that's financially impacting us. Thus, we can also really manage it and mitigate it. And yes, so what we did with them is really knowledge exchange workshops on the basics of climate change. And in addition, also working with them on expected losses, and risk engineers got into the field with them for planning their new locations in the renewable sector. And the last case I quickly wanna introduce to you is a company that's doing investments all around the globe, also for renewable energy. So they are buying and building wind farms, solar fields, hydropower plants, and for them it's very important when they invest in a location that the conditions will still be favorable some years in the future. So, for example, if they're planning a new hydropower project in Asia, they want to know that there is not a constant drought in the future, so that there's enough water still to produce hydropower. They had the experience that they built a solar field, and shortly after, only a few years later, it got impacted by a hail event. So they were not aware of this risk, and so this is really crucial to them when thinking long term to take these risks and the changes in these risks into consideration. And also what I found personally very powerful is that they brought not only their risk team into the picture, but also their sustainability team. And the two streams of risk and sustainability got to work together on the same data and the same platform. And so that I think was also very good for them internally to bring the teams together. And now whenever they're thinking of a new investment, they will do a climate risk assessment and report by risk engineering experts and climate risk experts to get some insights on how the risks are gonna evolve in the future. All right, two companies. I'm not sure if you know them, but EGA is a company that works with wood and building materials. Headquartered in Austria, and we've been working with them, especially since they are not only their production sites are impacted, but also the resource, of course, so wood. And so we worked with them on a climate risk assessment, and also Holcim, a big cement plant, which you guys probably know. Also, they are assessing their physical climate risk. All right, that was it from my side. I would be super curious on questions. I hope my video didn't get stuck.
Thank you very much, Annamarie, for the incredible presentation, very insightful. There is already a question on the chat from Marco to Giacomo, and hopefully more questions will be flooding in and people will unmute themselves and ask the questions. Is Marco still online, or shall I read the question?
Oh, thanks a lot. As you prefer, Valentina.
Go ahead, Marco, please go ahead.
So first of all, compliments. Just a curiosity, is your portfolio concerning seismic vulnerability fragility cubes for underground infrastructures such as caverns, tunnels, or shafts also, or is still a topic still under development as we know, this is a topic that is at the forefront of geotechnical structural engineering, right? So.
Okay, thank you, Marco, for the question. I mean, it's a really interesting question. Can you please unmute? Okay, thank you, because it was a bit noisy.
Sorry,
thanks.
office.
I see. Thanks for the question. And yes, for sure. I mean, that's a really important topic. And the answer is yes, of course, we can model underground infrastructure within our CAT models. But I think it's important to mention, so we have actually a set of fragility and vulnerability curves, in that case, specifically vulnerability curves for this kind of structure. What is important to mention here, I think, is that this really depends on the kind of underground infrastructure that you want to analyze. So, for example, if I don't know, a company has a specific need, or your underground structure a bit peculiar, because I saw you work at CERN, so I can imagine that your kind of underground infrastructure are something that goes a bit, beyond the regular underground structure that we may find in civil engineering. For sure, we can actually we can run this kind of model. But what I was actually mentioning is that in Aeon, I think we are in a unique position in the market for this kind of CAT analytics services, as we have impact forecasting within the group, which is a company that actually develop models and actually offer bespoke services for companies that need specific CAT analytics services or specific models. So I would say that, yes, in general, if you want to model the average underground infrastructure, I'm pretty sure that we can easily do it in a simple, basic, let's say, CAT model. But of course, if you want to do something more in detail or something that require a bit of more attention and it actually requires some, some specific expertise. I would say that at Aeon, at least, we may do such a kind of work thanks to the partnership that we have with Import Forecasting. I don't know if this answered your question, but it's actually quite a broad topic, I think.
Yeah, thanks a lot. For something a bit more personal, we'll WhatsApp you.
Thank you.
Any other question from the audience? I've got one for Annamarie, actually, out of curiosity. The Sustainability Compass platform is obviously extremely interesting. Just out of curiosity, what is the biggest change in materiality that you are observing by using this very powerful tool? If you're allowed to share.
Sure.
In general.
I think for most companies that we work with, the whole heat stress and heat wave topic has not fully arrived yet, and we also don't know the full implications yet. So health implications of heat stress in Europe, we're not prepared with air conditioning, for example, and so this coupled with drought, I think this is something we really have to brace for. The changes in the flood risk, of course, that's from a financial impact that is probably more driving. But there is less of an increase in the delta, I would say. But really, like the drought and the heat topic is should be on our agendas. And it's also an opportunity for risk engineers, of course, for engineering to find new solutions.
And just because you mentioned, we've certainly seen the natural events that you mentioned, so floods and earthquakes, but are you also opening up towards man-made perils, such as, for instance, cyber, which is another kettle of fish?
I have to say that's not my core expertise. It's not part of the sustainability compass because, as the word says. But I think it's another important factor, and there is separate cyber models trying to, as good as possible, model the risk of cyber attacks. Yeah, Giacomo, do you have insights on cyber modeling?
Well, for sure, it's one of the emerging risks. I don't know if it is still an emerging risk or if it is the risk of the future, because it's already here. And the amount of risk related to cyber is pretty high. As Annamarie said, of course, it actually requires some specific expertise. It isn't something that you can actually do so quickly without having that expertise. But of course, I mean, it's an important topic. I think everybody's investing on that direction.
There is another question. Is the Compass tool open for your clients?
It's open for anybody.
Good to know.
May I ask you a question, Annamarie? It's actually related to the communication, basically to our clients, to the customer, because something that we noticed here, at least, or in my experience, sometimes when we have to talk with your clients about climate change or ESG related topics, it's quite tough to really communicate the variability of the results that you may have because of the uncertainty that are, of course, in the climate change process itself. So in your experience, what kind of clients have you worked with? Did you see, let's say, an opening in this direction to really understand what the problem is? Do you see an interest or I know it's a very broad question, but I think the communication is tough.
Uncertainty is a tough topic, and because companies or sustainability managers, risk managers, they want to know one number. That's going to be the risk in the future, but you really have to communicate to them as well. And we're giving 3 climate change scenarios. That's the first sensitivity for them that they need to decide for one or consider all of them. And also underlying, we can also share the percentiles of the modeling, like the 9th and the 10th percentile, and then you see how wide the results can be. But the people that we're talking to on the company side often don't have that sensitivity yet. So that is quite some teaching to do. Yeah.
True. You have to educate somehow the market and the clients. Yeah.
Of course, but that is not their field of expertise. So I understand they're business people. They want to know the single truth, and we don't have the crystal ball, as said. Yeah.
So.
And maybe on Guishi's question, yes, it's open for anybody, and it's a license tool. Very, very simple. Please just contact me if you're interested.
Great. Any more questions from the
Maybe
audience?
a question, just to take the opportunity to ask Giacomo a question. And thank you, Giacomo and Annamarie, for the great presentations and on behalf of the second young group. And I would like to ask about an aspect you mentioned about damage accumulation. That is something that is little captured by current CAD models. Maybe in light of the Turkey also earthquake, where two major earthquakes occurred very close to each other. So what can be done on a realistic scale, let's say, without going into the detail of knowledge about each building?
Yeah, that's a great question. I mean, the major problem here, in my view, is that we rely on probabilistic models that don't really account for the sequence of events. So right from the beginning, when you build the hazard module, you don't actually consider the sequence. You actually take the main ground motion and you use it to calibrate your hazard. So if you I mean, it's something that you can actually do. You can develop a model that accounts for the damage accumulation. It would be a different level of CAT model, basically. So you would actually to rebuild the hazard in order to consider and calibrate the hazard based on the seismic sequences. You should actually consider the seismic sequences within your stochastic event set. And then you should build your vulnerability curve in order to condition the damage, not to a single input, but to a sequence of input, okay, to a sequence of events. So theoretically, it's something that can be done, but my question is, do we really have the data? I mean in the industry or anywhere in the academia, everywhere, do we really have the data to calibrate such a very complex model and make it reliable? That's the question, because otherwise we would actually end up in the situation where we have a super fancy model that actually can do everything, but we don't have data to calibrate it and we lose control over the uncertainty. So that's my main concern, and I think this is a bit the concern of the industry. But that's a great question, I mean, and we are really looking into the topic also to find different ways to model the seismic sequence in parallel to the development of models that may actually account for the damage accumulation. So I know it isn't an answer, it's more actually an open question.
I think it's a great topic that I think has many ramifications either in the industry or both in the industry and also for engineers in general, and for the second community, definitely. It's a great topic. Thank you.
It seems there is no more question from the audience. So with that, I'd like to thank you both for the great presentations that you've shared with us. On behalf of the Young Second Subcommittee, a big thanks to you both and to the audience. And stay tuned because the recording will be made available soon on our YouTube channel. So thanks a lot and see you soon.
Thank you, guys. Thank you.
Bye.
Have a good day.
Thank you.
Thank you. Thank you very much.
Bye.
Bye. Thank you.